Hi and welcome to this video focusing on specific pre-processing actions, and we will be looking specifically at the different data types that you would deal with in a Python code in your data set. In the previous video, somewhere up here, I introduced you to the test cricket data for South African cricketers from the period 1991 until 2023. We loaded the libraries up top here. You can see we loaded the libraries right on top over here. And then we did a very brief overview of the data, just observing what the main features are and getting a feel for it, getting a sense for it. We noticed a few interesting little cells that might be problematic from a data analysis point of view, which we will deal with in future videos. So keep an eye out for those future videos at the end of this video. We looked at the tail, we looked at the head. You can play around with the tail, but have a look at the previous video to go into a bit more detail with regards to that. So in this video, we're going to be looking at different data types. Why is that important? Well, one cannot analyze the data if you don't have the appropriate data types. So we need to know not only what data we have, we need to know whether or not the data is clean, and we need to clean the data, and that'll be done in future videos. But we also need to know what type of data we have. So you'll see here that I've highlighted under section 1.3 specific pre-processing actions, and the coming videos after this one, we will deal with specific topics in this pre-processing workflow when you analyze your data. So I click on this cell over here. Remember, if it's highlighted in blue, you know you've selected that cell. And remember, Shift Enter or Shift Return outputs the code that is in that particular cell. So let's just give it a moment there. It's busy thinking. So we can see from this output, what I have asked in this line of code is, I've asked Python to go through all the respective columns. Remember, the columns are highlighted at the beginning of the Jupyter Notebook sheet. And in this data dictionary, you can see what the respective characteristics of the data are within each individual column. So if you look at, for example, player, the 123 means there are 123 cells that are unique. In other words, 123 different cells with different information on it. Now, we haven't looked yet to see what type of data is in each respective column. That we'll do in a moment. But what is important to notice is that if you have a quick look at this, you should have a sense of whether or not there are unique values and the extent of the unique values in a respective column. So if there are 123 unique player columns, what that tells you is that there are 123 names and surnames. If there are 93 different spans, it means that there are 93 different years, or a range of years rather, where the respective cricketer has been a test cricketer for the South African cricket team. So that makes sense. There would be some cricketers who have played for the same span or the same period, in other words, maybe 2001 to 2004. When you look at matches, there are 50 unique values. So of the 120 rows, there are 50 whose matches are unique. So if there are 125 rows, which we got from the data up top here, remember, up top here, then it means that there are 75 rows or cricketers that have the same number of matches. Just for interest's sake, remember there are 125 rows, but here there is an indication that there are only 123 players. So that's an interesting one, because that means out of the 125 rows, only 123 are unique. That could indicate that there are duplicate values. So you can have a look at these values here and get a sense for it. If you look at the handball, for example, and the hand bat, you would expect only two unique, left hand or right hand, bowler or batsman. When you look at the type of bowler, 9, right? So if you go back to the top here and you look at the data dictionary, the 9 should be these 9 listed over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it makes sense. So keep checking your data. And that's the thing. You've got to get a sense for the accuracy of your data and whether or not it is a true reflection of reality. Because it's very easy for data sets to have spam, to have dirty cells. Keep cross-checking yourself and get a real feel for the data. So the next line of code, what I do here is where I considered the number of unique values in the data with output number 14. In input number 15, what I'm asking Python to identify is the specific data types that are in the data. The player column or attribute is an object. The span is an object. Matches, mat, is an integer. From innings right onto handbat, they're objects. You should already start feeling, but this is not a true and accurate reflection of the content in a particular column. Because something like runs scored, it's a numerical value. But an object, if you look down at the bottom, is basically a string value. So it's text. Why would runs scored be an object data type? So that means there could be something wrong in the runs scored. There might be one cell that is a string, and then it makes the entire column a string. If you look at innings bowled, it's a float, which is probably correct. I mean, the number of innings bowled would be a number, and a float is a number with a decimal. So for analysis purposes, you can leave it as a float. You don't have to change it to an integer, although an integer might be a more accurate reflection. Float is fine. Runs conceded float, wickets is a float, economy rate is a float. That's an accurate float because an economy rate might be something like 3.27 runs per over, whereas runs conceded will not be a float. So it's important to get a sense for the data in that regard, and you can clearly see that there are a few data types that might need to be addressed, or in fact that should be addressed. So what I've done over here is I've just given you an indication as to the different types of visualizations that you can use for specific types of data. When you have object or string data in terms of univariate analysis, remember, when we do the exploratory data analysis, the EDA, you have to do univariate as well as bivariate analysis. So in terms of integer data, for example, you can use univariate analysis using histograms, bivariate using scatter plots. For floats, which are numerical values as well, you can use the same histograms and scatter plots. For categorical data, you can use bar charts and, for example, stacked bar charts and heat maps, group bar charts, pie charts. So there are multiple different types of visualizations applicable to particular data types. And that's important to understand when you start exploring your data in more detail. So the next line of code, what I do there is I want to change some of the columns into categorical variables. And I know specifically that handbat, type, and handbowl are categorical variables. How do I know that? If I go back to my data dictionary, handbat, left or right, 2 categories. Handbowl at the bottom here, 2 categories. And type is also a category. It makes sense then to change these variables or these columns into categorical variables. So let's have a look there. I've run the code, and if you run the code, you will notice that there is no output, but the number 16 shows. So there's no error as well, which means that Python has actioned that line of code. So if I now go to the next line of code and I ask Python to let it run, you'll see handbat, type, and handbowl. If I scroll down, handbat is now a categorical variable. So is type, and so is handbowl. That's great. Another way to show the data types is data info. So where on top you use print data types, here you use data.info. You'll see it lists the column, it lists the count, and it lists the data type. You can also get a sense here. If you look at the players, you would expect there to be 125 players because that's what the number of rows were indicated on the code above. But as you go down, you'll notice that all these variables over here, these columns, are batting columns. You would expect that most, if not all, test playing cricketers would have at least batted once. You would, however, also expect that not all the 125 cricketers would bowl. So you would expect then, if you look at the bowling stats or the bowling data, that it will not equal 125 because not all the cricketers bowl. Some are wicket keepers and some are just not bowlers at all. So it makes sense then that the number applicable to the bowling data, the numbers are noticeably lower. Just another way of checking your data and getting a sense for it. Now, let's look at those two categorical variables. And what I want to do is I want to highlight what the unique values in them are specifically. So I run that first line of code, number 19. There's no error. There's no output. So it tells you that Python has actioned the code. Now I run that line of code, which is a specific line of code that generates this output in terms of the tables and columns. So it says print unique values in I, and I is in this Coles cat over here. And the Coles cat was specified in line 19. We are going to look at the columns in Coles cat that are categorical. Print the number, value counts, and the output is shown over here. So in other words, unique values for handbat are handbat, that's the column name, right-handed, 93. So there are 93 batsmen that are right-handed. There are 32 batsmen that are left-handed. So what that means is approximately 1 out of every 4 cricketers are left-handed. So give or take approximately 25% of all cricketers that have played test cricket for the South African Proteas cricket team are left-handed. 1/4 of them. 1 out of every 4 cricketers to bat. If you look at the type, what you will see here is it lists the different types of bowlers as well as the wicketkeeper, because remember we added the wicketkeeper option as a category. And what this shows is out of all the bowlers that have ever bowled since 91 for the South African national cricket team, the most type of bowler are off-break bowlers, off-spinning, off-break bowlers. The second biggest category is your medium-fast bowlers, followed by your fast-medium bowlers, your medium-slow bowlers, and then your medium bowlers, your fast bowlers, your express pace, and your leg break. So you should be able to get a sense here that if you look at all the bowlers that have bowled for the Proteas team since 1991, the 2 types of, or let's say the 3 types of bowlers, the bottom 3, that are represented the least is probably an indication of the level of skill or ability attached to that type of bowling. Leg breaks would be the type of bowler that has featured the least. Leg break bowling is not easy. Express pace, very few cricketers, very few bowlers are express paced. And then fast, which is slightly slower than your express pace, is the 3rd smallest category. Bowlers that you would regard as being the smallest cohort, if you could group them together, it would be your really fast bowlers and your leg break spinners. In terms of your bowling, 78 are right-handed and 21 are left-handed. Now, if you add that together, it equals 99. So what it means is approximately 1 in every 5 bowlers are left-handed. In terms of the batsmen, 1 in every 4 batsmen are left-handed. But in terms of the bowlers, 1 in every 5. Relatively speaking, there are more left-hand batsmen than left-hand bowlers. And these are the sorts of data touch points that are interesting. The last line of code describes the code in specifically now the categorical variables. So it just reinforces what I've just said up top here. So in terms of the count for the type of bowler, there'd be 108 bowlers, including wicket keepers. The wicket keeper is 10. Now you'll notice now there are 108 type. But if I add 78 plus 21, I get 99 plus 10 is 109, not 108. So something is not right there. There's one cell and thus one row where there could be something not right. Keep that in the back of your head. Make a note of that, a mental note of that. In terms of the bowlers, there are 99 as indicated over here, and there are 2 unique left and right, and the right-handers would be 78 in terms of the frequency. So I've made a few conclusions over here. One is that there is the possibility that some categories that are regarded as being object data types should be numerical values. But because in this case, or this example, there is a situation where you have a bowling figure which is 6, 4, 32, and it's denoted with a string symbol in the middle of the numbers, that needs some further pre-processing. There are also funny symbols like asterisks, dollar signs, hashtags, @ signs. So there's definitely some very important features of the data, characteristics of the data rather, that we need to consider. In the next video, we will be dealing with incorrect or unwanted observations. So have a look at that video.